Good afternoon, everyone. So, in continuation with the previous session, so we have discussed till MapReduce, right, and processing layer. So now let us somehow theory part we have. Let us discuss. So, job tracker. So in the processing layer, Hadoop Onyx processing layer, we have job tracker and task tracker, right? So job tracker is the master node, and task trackers are slave nodes, slaves in processing layer part. Okay, so let us discuss. We have already seen job tracker, task tracker. So job tracker is a master, task trackers are slaves in MapReduce architecture, processing layer. Okay, so then let us see. Job tracker is the master node of MapReduce framework, and it keeps track of all the tasks, task trackers and resources they have. So it means what is job tracker is the master in processing layer MapReduce framework, and it keeps track of all the jobs. Also, it keeps track of task trackers and what and all resources task trackers have and how it is working. So maintain the life cycle of the jobs till it finishes. For example, so a developer submit a job from when starting to ending. It means when submitting the job and then assigning the resources and then job life cycle, starting getting the resources, getting the data and analysis, and then completion of the job and sending the result back to the client. So everything will be monitored. Maintain the life cycle of the job. Who will maintain? Job tracker will maintain. And each mapper and reducer state is also acknowledged to the master. So what are the working on mappers and reducers in the MapReduce layer, processing layer? So we'll be reporting to acknowledged to the master. And also job tracker is responsible for resource management and job scheduling. So resource management means in the cluster, each and every machine is having some resources based on the CPU RAM. Based on the CPU RAM, the resources will be calculated, and then each and every machine is having some resources. That resources, all throughout the cluster resources, available cluster resources, it should be maintained by job tracker. And also scheduling of a jobs also will managed by job tracker in Hadoop Onyx processing layer. Okay, then let us see the task tracker. Task tracker is the slave node of MapReduce framework. So these are the slaves. Task trackers are slaves. So and also an instance of task tracker daemon runs on every slave node. So a daemon means service. A service of the task tracker will run on every slave node. So slave node means what are the slave nodes we have in the cluster? Data nodes are slave nodes. So each and every data node, task tracker daemon is running. So receiving the processing request from the job tracker, it receives whatever the submitted jobs by the end users, clients submitted the jobs, and from the job tracker they will send it to task trackers. It means it will receive the job request from the job tracker and run each MapReduce task in a separate JVM. So the task tracker duty is whatever receiving the jobs. Okay. Okay. So what are the jobs running? So everything will be monitored by job tracker, and also it runs on each MapReduce task in a separate JVM. For example, if users are submitting the tasks, right? So each and every task will be submitted to task trackers, and that task tracker duty is each and every job receiving from the job tracker job will be runs on separate JVM. JVM is like container. So inside the JVM container, jobs will be executing. And also it is responsible to update the status of each MapReduce task to job tracker. Okay, and it is responsible to update the status of each MapReduce task to the job tracker. Total number of task slots need to be balanced with maximum amount of memory allocated to job Java heap size. So that is the task tracker duty. Okay, so this is the task tracker. Then how the task tracker will be working? So how MapReduce program will work? For example, if you see the diagram, there is a left side, there is an input format, input file. Input is nothing but a file. Any one file if you have in your Hadoop cluster, any file, if you take it any of the file. So if you want to process the file, so first it should splitting. So when the MapReduce task MapReduce framework, how the program will work. Okay, so when you started a program, first of all, this is the input file. So input file should be split into small pieces like this way. It will happen splitting inside the internal program. It will happen splitting. Then mappers will try to map the number of words or whatever it is, whatever your program. For example, if you are trying to identify number of words, for example, if you are trying to run a program with word count, so it is try to count the words available in the entire file, and then it will mapper will process the input files, splitting, whatever the splitting done of the input files will process. Then after that, shuffling will happen. Sorting and shuffling will happen. Then it go to the reducer phase. Okay, so reducer phase to reduce the output. For example, see in the splitting area, if it divided 10 to 15 splits, then based on when after the sorting and shuffling, from the 15 splitting input files, small input files will be reduced in the reducing area. Then final result will be one file output. That is the overall your analysis. That is the way MapReduce program will work. Okay, so for this we'll install a Hadoop One cluster, Hadoop One-X cluster installation, and we can see some theoretical part like Hadoop, how Hadoop will be loading the data. We'll try to load some data into Hadoop and how to check the data. Then we'll try to run some MapReduce framework, MapReduce sample program. We'll try to execute it. Okay, so let us see. Okay, so we'll try to install Hadoop One-X, and then we can see some Hadoop operations like how to create a file and how to load the file from local to Hadoop, how to check the files in Hadoop, some of the moving, copy, data moving operations, and then we can try to run that storage layer operations, and then we can see some of the processing programming part. It means try to execute some sample programs. Okay, so let us see. Let me open installation document. So we are going to install single node cluster in Hadoop One-X. So version is Hadoop 1.2.0. Okay, so you can see I have taken one machine. So I am going to install the Hadoop. So we need a Linux machine. So I am using CentOS 7. Okay, so host name, what is the host name I am going to install? Hostname -f. So my host name is master.hadoop.com. Here Linux machine, this is the Linux machine which is installed already. So you can see Linux file system, local file system, you can see it here, ls-la. So you can get all the details, ls-la. You can see Linux file system, it is available. So now I am going to install on top of Linux, I am going to install Hadoop 1.2.0. Okay, so let us see. Then I have a document. So I have a document, so IP address, machine name, my host name, then what are the roles available in storage layer, name node, data node, secondary name node, and the processing layer. We have two layers, right, in the Hadoop: storage layer, processing layer. So processing layer we have job tracker, task tracker. Okay, so we are going to install Hadoop 1.2.0, and which is already downloaded in this Linux machine. If it is not downloaded, go through this document, this path, and you can download. Okay, so which is already available in the downloaded, so no need to download it again. Okay, then let us see. So before going to install, so I am going to create passwordless SSH. Okay, so let me try to execute the command. Let me clear the screen. Passwordless SSH. So I have created a passwordless SSH. Okay, so then I'll connect from the name node and data node. So this is the Hadoop One-X Hadoop 1.2.0 tar file, which is already available and downloaded and put it in this this Linux machine, this path. So where www HTML Hadoop tools, my Hadoop software is already available. Okay, so I'll try to execute the commands, and I'm going to remove if any file is available. So the software is available in this path. You see, this is the software in this machine, Linux machine. So from here, I'm going to copy into user local. This is the one path in the machine. I'm going to copy and extract the software. Extracting means unzipping. So that is a tar file. So I am unzipping it. Okay. So I have done the unzipping. Then I'm creating a link. Right. And I am going to change the owner of the Hadoop folder. Right. I changed it. Then you can see ls-ltr with user local Hadoop. So this is user local Hadoop is pointing to user local Hadoop 1.2.0. Okay, so we have downloaded and placed the software into one of the folder called user local Hadoop. Okay, so now third step 3, step 1, step 2, step 3. Step 3, so set up the home directory. So open this file, go to press I, go to down, and Hadoop home path we need to setting. So this is the Hadoop home path and Java home path, Hadoop setting everything, which is already available here. You see, Hadoop home path, Java home path, export path is everything is available. So if it is not available, you have to copy and paste this one from this document to your Linux machine, which is already available. So I don't want to change it anything. So save and exit, then clear the screen, then open this Hadoop environment file, Hadoop env.sh file. Okay, press I, go to down, go to end, and press enter. Then copy this file, export to Java home path. Okay, Java home path, save it, save and exit. So environment file we have given Java home path. So then coursei.xml, coursei.xml. So I have opened coursei.xml, and there are some Hadoop input output operations, so which we need to provide it here. So here our dfs.default name equal to master.hadoop.com, that is our URL. So I have given the URL here. Then go to hdfs-site.xml. So these are the important configuration files in the Hadoop environment, right? coursei.xml, hdfs-site.xml, mapred-site.xml. So which we need to configure. Okay. So in hdfs-site.xml, I am going to configure. So we are installing single node cluster. So that is what default.replication factor I have taken 1. So replication by default replication factor 3. But I am giving only 1 because one data node, single node cluster we are going to install. Okay, then let me take it other also. So disk 1, disk 2, I am giving here. We need to create a disk 1, disk 2 in same file. Then other one also, disk 1 for name node storing, name node metadata, disk 2 for actual data storing. So I have given 4 properties. Then go up. Then open the slaves file. We need to slaves, data nodes. What are the slaves we have? So data node details we need to mention. So we have only one slave here, one data node. So 192.168.1.201. So that is the slave node here. So I have mentioned. Then etc profile. Then create the logs files and change the permissions for the Hadoop logs. To rotate the Hadoop logs, we need to create log files for Hadoop. So I'm changing the full permissions. Okay. Then next one, we need to create some disks, 2 disks, right? So create a disk 1, MNT disk 1 for name node data storing. It means what is the name node data? metadata. Okay, then changing the permissions of Hadoop user, Hadoop admin for the owner of the disk 1 MNT. Okay, change it. So we created a disk 1. Now we need to create a disk 2 for actual data storing into single node machine. Okay, so we created, then change the owner of the MNT also. Then the last one, MapReduce layer. So as of now we have given all the properties for storage layer. Now MapReduce layer, you can see it here. To enable MapReduce layer, I'm highlighting. So you can open this mapred.site.xml file and give the property. You need to enter the property. What is the MapReduce job tracker? This is a job tracker. Okay, so I am giving localhost file. Okay, then we have configured the all configuration files. So as part of Hadoop, we have taken on Linux machine. So we have downloaded Hadoop software and we have configured the Hadoop configuration files. Then next activity, we need to format the name node and we need to start the Hadoop services. Okay, so to format the name node, we have a command to format the name node. So it is asking some file system is already available. You want to format? Yes, I want to format it. Now I have formatted the name node. So it means we are going to install a fresh cluster, fresh cluster, right? So new cluster. So that's the reason, new single node cluster. So I am formatting. I want to format the name node. Okay. Then using this below, start the name node. So I'm going to, I have formatted the name node. Then what is the next step? Next step is to starting the Hadoop daemons one by one. So first we'll start with name node. So we have started, but how to check name node is started or not? So click on JPS command. You can find the name node running, name node with process ID. Similarly, start with data node. So start with data node. Data node also started. Check JPS command. You can find both name node, data node, both are running. Similarly, we can start with secondary name node. Secondary name node, right? That is also one of the component in Hadoop, right? Storage layer. Started. So click on JPS command. JPS. You see, name node, data node, secondary name node, everything is running. Okay, so it means storage layer started. Whatever we installed the Hadoop cluster, Hadoop single node cluster, storage layer started successfully. Now we want to start processing layer. What are the processing layer tasks? Job tracker, task tracker. Okay, let us start it. Similar command. Job tracker and start task tracker. Okay, then let us clear. Then click on JPS command. You can find all the services, storage layer services, processing layer services. Everything is running on in the command line interface. Okay, so now Hadoop services are running. Okay, so we can see and we can go and check Hadoop file system, any files are available. So how to check the file systems available in Hadoop? Command is Hadoop fs-ls root. Root stands for file system, Hadoop file system. Slash means root. So only temp directory is available. No files, because we have installed new cluster, right? There is no files available. Okay, so we need to load some files. Then we can see the files here. But we don't have a outside data. So what we can do? So we can create a sample file in the local file system. ls-la. So we have some local file system, right? So we'll create a sample file, test file, sample file, and we'll take some data from the internet and we'll copy the files to, we'll load into the file, and that file we can load into Hadoop. Okay, so I'll take some data from the outside Google. Let me take some data. So I'm taking some India history. So I'm taking some India history. Okay, so I'm taking some data, whatever we need, some data. Okay, so I'm just copying this complete data, whatever the data available, complete data. I'm selecting, copy. Okay, so this is very less data, so I'll take some Hyderabad history. Okay, so this is, we have large amount of data, so I'm copying, selecting all, copy, and I'm pasting in here, right? So I'm pasting multiple times. We need some file, any data, any file, we need some huge size of the file we require, some size, some MB. Okay, so I am save and exit. You can see here ls-la. So we created sample file. You see, sample file with size into local file system. This is local file system, Linux file system. Okay, but if you want to check Hadoop file system, what we need to add a command Hadoop. So this is Hadoop file system. How to check the Hadoop file system in Hadoop? We need to add Hadoop command, Hadoop fs file system -ls to list the files in Hadoop file system. Okay, so only one temp directory is available, /temp. You can see starting with D, stands for directory. So now this is Linux file system. So we have sample file, right? So if you want to see the data, sample file, cat file name, sample file name. If you enter whatever the data available in the file, it will display. This is the data available into sample file. Okay, so now let us create 3 to 4 more files using cat command. Cat sample1. Using sample command, using sample file, I'm going to create another sample1 file. Okay, then using both these 2 files, I want to create one more new file. So sample2. Using sample1, both data I am clubbing and creating one more file, sample2 created. You can see ls-la, 3 files will be available now. So sample file size 522, 454 size bytes, and if you see sample2 file, I clubbed both files, 522, 10444980 size. Right now I want to club these 3 files and I want to generate a new file, sample3, clubbing 3 files, right? So ls-la, you see sample3 file size double, right? Similarly, we can generate new files like cat sample3, and I can create another file, sample4, right? ls-la. You see, like this way. So if I want to create a big size, cat sample4, 5 times I have taken into sample6. Okay, sample5 is not there. So let me create sample4. So total 5 files, and I'm going to create sample5. Created ls-la. You see, sample6 file, sample5 files, sample5 big size files we created. So we have some data available in 6 files total. So we'll try to copy the files, these files into Hadoop environment. Currently files are available Linux file system, local file system. Okay, so before that, let me go to So we have created Hadoop, we have installed Hadoop and started, right? So how to check Hadoop fs-ls. This is the Hadoop file system, right? This is command line, checking on command line, CLI, command line interface. Then we want to check Hadoop cluster status in web. Okay, so we have already a URL. So what is the URL? 192.168.1.201.50070 port number. You see, name node, storage layer. This is the UI, web UI. Okay, so you can see started, what date, today's date, version 1.2.0 Hadoop, and compiled, today's compiled. So any upgrades? No. So cluster summary, 6 files available, 1 block, 6 directories, 6 files and directories, 1 block. So what is the block? The temp directory also considering as a block in Hadoop. Hadoop is everything is a block, everything they will consider as a block. Okay, so heap size, what is the heap size? 64.5 MB. So okay, so configured capacity 20 GB, around 19.56 capacity. So distributed file system, non-distributed, so distributed file system percentage used, everything. And live nodes, data nodes, how many? 1 data node we have, so 1 block is available. Okay, so now only 1 block means what is the block? Temp directory also itself considering as a block. That is not actual block, it's a directory. But in Hadoop, so everything considered as a block, right? Hadoop file system. Okay, so then let us see. Okay, so now we'll try to copy one file from local file system to Hadoop. Okay, so before that, just check it. We don't have any, only 1 block, right? So now we are going to copy one file, sample file to Hadoop file system. Once it is copied, if we can refresh, blocks will be increased here. Currently block 1. Okay, now let us try to copy. Command is Hadoop fs-copy from. Where we are copying? Copy from local. We are copying from local file system to HDFS. What is the file name? Sample. Where you are copying? Into distributed file system. Okay, root is a Hadoop file system. We are going to copy the file into Hadoop file system. Copied, right? Then go to here. See, before refreshing, one block previously. So after refreshing, the blocks will be changed. See, 2 blocks. So 1 file we copied. 1 file we copied, sample file. Similarly, we can try to copy same files, other files. Sample 1, right? Sample 2. So total now 3 files copied. So it means total 4 blocks. 4 blocks, right? 4 blocks. And also percentage also increasing here. Okay. Then let us try to copy remaining files also. Sample 3. So we are copying all the files to Hadoop file system. So then sample 4, right? Then sample 5. Total sample 6 files. Total 6 files we have copied from local file system to Hadoop file system. Okay. Then go to here. So once I refresh here, you can change the percentage data also. It will be increased. Okay, just observe it. Percentage 0.22% increased, right? So total 8 blocks. 7 files we copied, and previous 1 file is total 8 blocks it is showing now in our Hadoop. Okay, so we'll go and check in command line how to check the files, total files. Okay, so let me clear the screen. Then Hadoop command is Hadoop fs-ls root. Root is a file system, Hadoop file system. What and all files we copied? These are the files, right? Sample 1, sample 2, sample 3, sample 4, 5, 6. Total 7 files we copied from local file system to Hadoop file system. So this is the Hadoop, where we can check the how many files are available in Hadoop file system. Okay. So now, if you want to create a folder in here, So one folder we have, temp folder, right? Similarly, if you want to create a folder in Hadoop, what is the command? Hadoop fs-mkdir, and so we want to create a test folder name test. So mkdir is a command to create a directory. Okay, so that is a Linux command mkdir, but here we are going to create a directory in Hadoop. So that's what we have added a command Hadoop fs, Hadoop file system hyphen mkdir. I am going to create a directory in root level, Hadoop level. Root stands for Hadoop, distributed file system. So Hadoop file system, and what is the directory name? Test. So done. So if you want to check whether the directory created or not, so currently you can see here, so in this available files in Hadoop, only one directory, test directory, temp directory. There is no other D. These are files. Files is normal files. It's not a directory, but temp is a directory. So we created one more directory. Now let us check. Test directory created, but 0 files. You can see 0 files. Okay. Similarly, if you want to copy a file from local file system to Hadoop, inside there is a directory. For example, inside you create a directory, test directory. If you want to copy the test directory, the files, okay, Hadoop fs-ls slash Hadoop fs-copy from local. We are going to copy sample file to test directory. Okay, so I am going to copy sample file into directly not Hadoop. Inside the Hadoop, there is a test folder. Inside the test directory, I am going to copy it. Copied. But how to check? So earlier, when we executed files, it is showing 0. Now it will show 1. Okay, it shows 0, but let me log in /temp test. You see, one file is there, sample file, right? So this is the way of loading the data from local file system to Hadoop file system. Okay, so we have seen how to load the data from local to Hadoop and how to check the data. Okay, so let us see some more operations like, so now we copied the data, right? So we copied the data like Hadoop fs-ls. We know we copied the data, right? So now we'll try to move the data. So where is currently data is available in Hadoop file system. So we'll move some of the files from here to test folder. So moving, okay? So Hadoop fs-mv file system move from sample one file, sample one to where we want to move test folder. Okay, let us move. We moved it. So if you go to similar command here, sample one file will not be available anymore. It will move to test folder. MV stands for move command. You see, sample one is here available. So here no more sample one, sample two, sample and sample two, right? So sample one we have moved to test folder. Go to here and test folder, test. Then you can see two files. One is sample, already earlier we copied and we moved. Similarly, we can move other files also. Let us check. So move sample 2. Okay, then sample 3. So we'll move all the files to from Hadoop to inside the one more folder in Hadoop. Okay, similarly, let us create one more folder. Hadoop fs-mkdir will create one more. What is the folder will create? So data folder will create a data. Okay, so now we'll create some more files to data folder. We'll move it. Hadoop fs-mv move some sample 4 to /data folder. Okay, similarly sample 5, sample 6 as well. Similarly sample 6, total files we moved it. Also we'll move to sample file also. Sample also available in main root directory. Okay, so now let me clear the screen and execute hadoop fs-ls. Let us see. We don't have files. Of all the files we moved to test and data folders, right? We moved it. Okay, so now you can go to just test folder and similarly data folder. So this is the way of checking the files available in the folder. So 448 files are available total, right? So this is what, and if you go and check the directories blocks, it increase. So 9 blocks. We created a data folder, right? So that is what increasing the file. So if you want to go and check the browse the file system, what are the files we loaded, it will display. Let us see one by one. So if it is not loading, then we can provide the IP address. You see, these are the directories. If you open data, so we have files, right? Go to the parent directory and test. These are the files. So each file, and also when you open, so when you open test folder, you can see what is our replication factor, single node cluster 1 we mentioned, and also block size Hadoop 1x 64 MB, right? So Hadoop default block size 64 MB. But what about this file size? Very less, 510 KB. Small data we have. So after copying all the files, total file is like total size around 3 MB or 4 MB. At least very less size, but each file it is divided into blocks like 64 MB block size, but actual file size is not 64 MB, less than the block size. Okay, so these are the owner of the file, group of the file, modification date, so timestamp, permissions. So these we will call it as metadata. These are all the details: replication, block size, modification date, permission, owner, group, size, everything, name of the file. So these all will call it as metadata. So metadata will be storing in name node, right? But this actual data is storing in data node, right? Okay, let us go to main folder. When it is not loading, just enter the IP. Okay, you can see now total how many blocks? Total 9 blocks and 25 total files are available. 9 blocks, 16 files and directories. Okay, so this is a live data node, and you can see storage directory, name node. What is that? FS image and edits will be active, storing in here. MNT disk1 name. Okay, so if any missing blocks, decommission nodes, if any unreplicated blocks, you can find it 0, right? And also, what are the other commands? So file system check, Hadoop file system, whether it's a healthy or it's a corrupted, how to check? Hadoop fsck is a command, file system check. You can see file system started with total size, this much size, total directories 7, total files, okay, and total blocks, okay, and also number of racks, number of data nodes, 1 data node, any missing replication 0, corrupted blocks 0, average block replication 1, default replication factor 1, and finally file system is healthy. Hadoop file system, Hadoop files are healthy, so it means it is working fine. There is no more corrupt on the file. Okay, so files are fine. We can able to read write files. Okay, so that is where we can find the Hadoop files level. Okay, so now we have some files available in Hadoop file system. So we want to remove some files from the Hadoop. We want to delete some files from the, for example, Hadoop fs-ls/. So you have some test folder. So inside the test, you want to remove from the sample file. For example, you want to remove it. You want to remove the file from the entire file system Hadoop. Okay, the command is Hadoop fs-rm. Remove a file. Where the file is available? Test sample file. Okay. So you see, file is deleted. File is deleted. Now go to and check. You cannot see the file. Earlier it is file is available here, right? Now we deleted the file, rm command. Remove a file. Rm means remove a file from the path we deleted. But now one more, if you want to delete a directory, which is already sample is test is a directory, right? Test is a folder. Folder means a directory. So if you want to delete a directory, first of all, directory should be empty. If directory is having some files, you cannot delete it. Okay, we'll try to delete. Hadoop fs-rmdir command to remove a directory /test. So, but test is already 3 files are available. In the test directory, we have 3 files available. Now I am trying to delete that directory, complete directory, test folder. Let us see, it will not allow, but let us try to do check that what is the error. So rmdir is a remove directory command. So I am trying to do it. You see, it is not allowing. So unknown command. Okay. So let us check one more time. rmr. So rm test directory, I am going to remove it. You see, rm cannot remove the directory because hrefs we can use, it is saying use rmr. Okay, we'll try to use rmr. rmr command. Remove directory recursively something. So, okay, it is deleted. Completely rmr command stands for remove recursively, even the data is also available, so we deleted. Now you can go and check Hadoop fs-ls / remove completely test folder deleted. Okay, and also generally when you delete a file in Hadoop, there is no recycle bin. So recycle bin in Windows, we'll call it as, in Hadoop and Linux, we'll call it as trash. So trash is by default disabled. So if you want whatever the deleted files, you want to move into trash, so we need to enable the trash file. But by default it is disabled. So whatever we removed the files, whatever we deleted the files, it is already deleted from Hadoop. So you can refresh it here. You can see some files reduced, some files count also reduced, right? That is what, where we can delete a files. But generally, if you are using rm command, if there are any files available inside the folder, which is not allowing. Okay, so but before that, we need to remove all the files from the folder, and then we need to delete the folder. So if you want rmr command recursively, means we can delete anyway. So that's the option of rmr. So it means we are confirming that remove anyway whatever the data is available inside the folders files. We have to, but make sure you should not use rm command in the Hadoop environment. That is very dangerous command. So it means if it is trash is not enabled, you will completely lose the file. So you will not get, if you have a backup, no problem. If you don't have a backup of the file, that is a very dangerous command, removing rm command, using rm command. Okay, so that is where we have seen copy, move, rm. So remove all 3 commands we have seen, right? Now let us go to the next one. So Hadoop fsck file system check files command. What are the files available in Hadoop? Okay, I want to check. So we have total 3 files available, right? Let us see what are the files. Sample file, sample 4 file, sample 5, sample 6, total 4 files available. So each file one block. Each file is stored as one block. You see, files. And the next one, what are the, each file is created in one block, right? What are the block names? I want to see it. Okay, and let us hyphen blocks. You see, sample file is this much size, and the block name is, this is the block name, blk, block. blk stands for some number, right? Some number. When you copy a file, it is creating one block, and block replication also, one, replication factor, and block name, right? This is a block name. So this is where we can see the files available in Hadoop. Okay, so let us see some more things. Okay, so we have seen storage layer operations. Now we can see some of the processing layer operation. It means we'll try to execute some program, sample program, and processing layer. Let me take some sample command. So running of a program, sample program, word count program. So I'm taking word count program. Okay, so where the file is available, test underscore sample, test or not test. What is the directory? Hadoop fs-ls / data folder. Okay, not test, data folder. We have, what are the files available? Sample file. We have sample 4, 5, 6, total 4 files available. So not sample, I am going to sample 6 file. Okay, so I am going to count of how many words are available in sample 6 file. What are the words, and each and every word how many times available. So I want to count. That is my word count program, and the result will be storing into output directory. Okay, so I am going to run this program from the terminal. Okay, so before that, this is storage layer UI, and let me open processing layer UI also. So this is processing layer UI. So for example, you can see any jobs you submitted, already completed jobs, everything we can show it here. Okay, so schedule, if any scheduled information, default queues, queue names, scheduling information, scheduler running, everything. So we can find it here. Let me try to submit a job and then we can see it here. Okay, so I'm going to submit a job for word count of file, sample 6 file available in data folder, and after the result I'm going to store it in an output directory. Okay, let me execute. So program is started, then go here, refresh. You see, one job is started, right? Job is running currently. 100% completed mapper, still running reducer phase. See, 33% running here, 100% completed. So job is completed. Now we can see earlier it is running job, now completed job, right? So this is where we can check the current running jobs in the Hadoop environment. We can go to here, we can see job started, first mappers executed, mapper 100%, then reducer 33%, finally mapper and reducers both are 100%, then job complete. These are the counters, job counters. Okay, so let us see. So Hadoop fs-ls root. So we have output directory created. What is output directory? Whatever the job we executed, that is output is stored in this path. Okay, let us open. So you can see in the output directory we have 3 files created. One logs directory, 2 files. So this is the result file available in Hadoop. Result of the word count program result. Okay, if I want to check -cat command. Okay, so let me open this command, this file. So if you open this file, that sample 6 file, whatever we have processed, how many words are there, and each and every word count, it will be displayed. You see, this is the complete word count of each and every word available in sample 6 file. So in the sample 6 file, we have, these are the words available in each and every word. So this word contains 448 times, this word contains 4032 times, and days contains 1344 times, like this word count. each and every word, how many times available in the file, and count of the words total. So this is the our processing layer sample file execution, and we can run the program. Okay, so let us see. So let us check the some of the theory part. So we have executed the program in the MapReduce layer, right? So next, so as of Hadoop Onex storage layer, processing layer. So we have seen the drawbacks like single point of failure in name node and job tracker. Okay, so to overcome that, what they have introduced, to overcome these drawbacks, they have introduced one Hadoop 2x onwards, one more node called standby name node. So in Hadoop Onex environment, we don't have any standby name node. We have only name node, secondary name node. But in Hadoop 2x onwards, to overcome the drawback of Hadoop Onex storage layer and as well as processing layer part, they introduced one more concept called standby name node. For the storage layer, they introduced standby name node, and Hadoop 2x processing layer, they introduced, so job tracker MapReduce layer is completely moved to Yarn. So Yarn is like processing layer in Hadoop 2x, and also the names also changed from job tracker, task tracker to resource manager, node manager. Okay, so let us go with some of the example. Explain the paint. Okay, so Hadoop Onex, right, in Hadoop 2x. So Hadoop 1x and Hadoop 2x. Okay, so Hadoop 1x architecture. Hadoop 1x architecture. Okay, then similarly Hadoop 2x architecture. So Hadoop 2x architecture itself changed. Okay, so Hadoop architecture also changed. Architecture level changed. Hadoop 1x we have one name node, multiple data nodes, right? So these are master slave and one secondary name node, right? So it is connected with all the nodes. It is connected with secondary name node. Name node, right? And secondary name node, right? And here data nodes. Data node 1, data node 2, data node 3, data node 4, right? Similarly, this is storage layer, right? Similarly, we have processing layer also, right? So processing layer also. Processing layer, what we have? Job tracker and task trackers in the down, slaves, ET. Task trackers. This is Hadoop Onex storage layer plus processing layer, right? Hadoop Onex architecture. In the Hadoop 2x architecture, they introduced one more node called standby name node. In the storage layer, so now both the name nodes are connected with all the data nodes. So this is active name node and this is standby name node. standby name node. They introduced architecture level, one active name node, one standby name node. So these are data nodes. Right? So data nodes. Right? Now this also active name node, standby name node also will be connected with all the data nodes. This is storage layer level. They introduced a change, and also they have created one more network drive to store the metadata, to storing the metadata. Okay, so this is NFS, network file system, to store metadata. And this node, this both name nodes will connected with NFS, network file system. This is architecture level. They changed it to, they introduced one more node called standby name node. So, but we have still one more name node, one more secondary name node is still available in the architecture level, but no use. If you want, we can configure it, but no more required. So still no one is using in the secondary name node, but still we have available in the secondary name node, but moreover that is not required because we have introduced a standby name node. So standby name node will work as a active name node. For example, if some of the scenarios, so here if name node is down, entire cluster down, but here if active name node goes down, for example, if active goes down, so standby will work as a active. That is architecture update in Hadoop 2x environment. So standby name node will work as active name node and cluster will running fine. But here some more disadvantage is also there. What is, how to start the standby name node? Who will start? Okay, so we have some more architecture types available in Hadoop 2x. Architecture type, this is first type, architecture, Hadoop 2x architecture first type. So we have second type, third type also available, that we can discuss. Okay, so okay, then second type in Hadoop architecture, Hadoop 2x architecture second type. So this should be generally, if this is down, this should start automatically and start the working as an active name node. But this is automatically, it should not start. Who will start? Someone should start, right? To someone, who is the someone? That someone we have to identify. So generally, what will happen if active name node is running fine? Okay, but some of the reasons, maybe network issue or any of the operating system issue or node issue. So active name node down means, so this should start automatically. Otherwise, cluster will down. So, but here there is system, machine cannot start automatically, right? Machine cannot start itself by own. Someone should start. Someone is like a Hadoop administrator, or we have some automatic mechanism. But here we don't have any automatic mechanism enabled in Hadoop 2x architecture first type. So NFS drive. So we don't have any automatic mechanism. For example, if active goes down, standby should start automatically. There is no automatic mechanism enabled here. It means it is not implemented. So automatic mechanism is not implemented. So to overcome this, that is a drawback in here. Again, in Hadoop 2x architecture also, the automatic mechanism is not implemented, right? So either Hadoop admin can start manually. Hadoop admin should start standby name node manually. But what will happen if the Hadoop admins are not available on the shift? So again, it is a cluster will be down. So to overcome that problem, they introduced in the one more automatic mechanism to start the standby name node. Okay, that is Hadoop architecture 2x architecture second type, that we can see further. Okay, so let us check. So they introduced some more automatic mechanism to start with using Zookeeper. Zookeeper is a automatic system which is automatically start If active goes down, so name node standby will start automatically start. That is a Zookeeper implementation that we can see for other session continuation. Thank you.